Hello, welcome back to Cracking the Cryptic and another fantastic puzzle in prospect today. This was created, I think, for Pi Day by Sir Wosel, and that was a few days ago, of course. The 3/14, as in 3.14, so the 14th of March is designated Pi Day, and Sir Wosel created this, but didn't send it to us until Pi Day was over, or very nearly over. So it's not our fault for not doing it on Pi Day. But it's a very clever idea. It doesn't actually have a lot to do with pi, the general mechanism, but the golden digits do. So we'll have a look at that in a moment. Don't forget that on Patreon, you can, on the 1st of every month, we have a new puzzle hunt, and next month it's April Fool based. And we're looking forward to bringing that to you. There are some Roggen clues in each puzzle. On last month it was Blobs' brilliant Nurikabe puzzle pack. And of course on Patreon there is other stuff, connections videos, crossword videos, all sorts. Do check it out. We've got all of our apps, which are brilliant and feature line Sudoku, and of course the latest Fog of War Sudoku. You can find them on the links under the video. You can look at our website, which is very much new and updated. That's linked under the video, and all our merch and SVEN'S SUDOKU PAD are linked there as well. Lots of stuff in the description field. Do check it all out. The first link, however, is to this puzzle, It's a Wonderful Day for Pi, and the rules are as follows. Normal Sudoku rules apply, so 1 to 9 will go in every row, every column, and every 3x3 box in some order. Now, mean diamonds. A digit n in a blue diamond means that the first n digits on any line leaving from that diamond, including the digit in the diamond itself, have an exact average of n. So I presume if this was a 4, these 4 digits, because n is 4, have an average of 4 because n is 4. So they add up to 16, I suppose. All cells on a line must be counted in at least one of those averages. Oh, I see. So if we're in the middle of two, yeah, every cell on a line must be counted somewhere. To celebrate International Pi Day, the digits 3, 1 and 4 appear in the golden cells, the 3 golden cells. Okay, it's a very simple rule set, but I suspect there are complexities ahead. Now, I don't know how hard this is, so I don't know how long it's going to take. You can look at the video length and maybe judge for yourself, although given certain recent experiences of errors and unwinding and fixing things, who knows what the video length means. I'm going to restart the clock and say, let's get cracking. So we can put 1, 3 and 4 into the golden cells. Now, 1 is a perfectly valid diamond number. It would mean that the one cell leading away from that diamond in one direction would have an average of 1 and would be a 1. Four would mean 4 cells in that direction I think we're always using squares, aren't we? Because if 4 is the number in a diamond, the 4 cells leading from that diamond sum to 16, so they can have an average of 4. So we're going to need to know our square numbers today. Oh, this is a long old haul though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits between those. Let's just have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Are you getting the impression that 10 is an important number? 10 again. And what about this one? This is not 10. This is 8 between those. And this one, 1, 2, 3, 4. That's 7. Okay, so the number between those is 5. I don't know what those mean, but oh no, I do know what they mean. That means this is not a 1. Okay, the reason I'm coming to that conclusion is that all these digits would have to be on a line that had an average, and that would require this thing to be a 9, But this is clearly factuously impossible, because for those 9 digits to average 9, they would have to add up to 81. They'd basically all have to be 9, and there'd be all sorts of clashes in rows and boxes and things. So this one isn't a 1 because of the direction of this line. In fact, once that is only 3 or 4, it can only get up to there. This digit at least must be included in the total from here. 1, 2, 3, 4, 5, 6. So this is at least 6 or 7. Could it be 8? Because that would require the first 8 digits to have an average of 8. That's not 8, that's 8. They would have to sum to 64. And you could get 24 there, another 24 there, 9, 8, 7 in each case. That's 48. Oh, these two would have to add up to 16. Oh, they could do that. Well, maybe I can't rule out 8, although it seems remarkably implausible. Actually, if that was an 8, 8 would have to apply on this line as well, and that's not going to work, because these 5 digits have a maximum of 35. These 3 would have to add up to 40 something, 49. No, 29. To make 64. 29 is too much for 3 digits in one box, so that's not an 8. That is 7 or 6, and these two have to add up to 10 at least between them to get everything on the line. Now, can this be a 1? This digit would be in this count, so that would have to be at least a 7. 7 cells, could those add up to 49? Oh, maybe they could. Does that mean I cannot rule 1 out of here? That's so irritating. I think it does. Okay, this one, well, I mean, this is only going to get a maximum of 7. That's at least a 3. There might be digits I could rule out of here. If this was a 6, all of these 6 would have to sum to 36. And these ones would add up to 30. And then by Sudoku, I don't know. Let's think about, can this be a 1? If I can say this isn't a 1, well, one of these two is a 1. Ah. No, I don't know. If that was a 1, this would have to be a 7, and that would have to be a 6. All the 7 going this way would have to sum to 49. The 7 going this way would have to sum to 49. That 7 would force this to be a 6. Oh, that's interesting. That would force this to be a 4, because these two have to add up to 10 to cover every cell on the line. So if that was a 7, this would be a 4. That would count those 4 cells. These would add up to 12. And if this was a 7, these would have to add up to 7 there and 9 there. These would have to add up to at least 33. 7 and 9 and 33 makes the 49. You have 33 minimum, 12 exactly, and that would be a 0. Because of the total of 45 in the central box. Right, let me try and explain that again. If this was a 7, this is quite important actually. If this was a 7, these cells would have to add up to 42. Even if you allow that to be a 9, these now have a minimum of 33. That being a 7 makes this a 6 by Sudoku, which makes this a 4 by the length of the line connecting them. That 4 makes these add up to 12. They're 12, that's a minimum of 33. That is at least 45 in those 8 cells. But we know the secret, that every row, column and box adds up to 45, and that would leave nothing for here. So that is not a 7. I think we can rule out 8, not just because this line can't be 8 cells long. Well, actually, that would probably be fine. But also, we'd have to make these add up to 64. And even if you put 13 there and 8 there, you'd need 43 from those. That's not possible. So that is not 7 or 8 or 9. It is less. And the important thing about that, I mean, I don't know what it is, but it does mean that it doesn't count that cell because it's no more than 6 counting this way. So that cell has to be counted by this, which is not a 1, and that's now the 3-4 pair in the golden cells, and that's a 1 in the middle, which is not, of course, in a diamond. Doesn't really matter for that. Now, where the 3 looks into this, it's going to pick up the 1 and a 5 in one of those cells. Where the 4 looks into the center, these two are going to have to add up to 16 minus 1 minus 4, which is 11. And one of them's a 5, so they're now a 5-6 pair. That's really interesting. And in the 5-6 pair, the 3 will be touching the 5, and the 4 will be touching the 6. Now, that's only getting 3 or 4 cells done in this direction. So this now has to be at least a 4. It's got to get that cell in minimally. This is 6 or 7, so we know that's at least, what is it, 3. This is one of the 10 lines, isn't it? That's at least a 3. Oh, that's... So this is 3, 4, well, it probably can't go as high as 9. Well, 9 is always impossible in these diamonds because it requires every digit on the diamond to be a 9. I think 8 is impossible on this one because these would have to add up to 64. They have a maximum of 30 from 4 digits there. They have a maximum of 24. That's 54, and the 8 there would be 62. Right, this is 3, 4, or 7. And that leaves only 3 different totals for this group of cells. From the 45 in the box, we have 12 there, and then 3, 4, or 7, 15, 16, or 19, leaving 30, 29, or 26 for that group. Now that does allow this to be a 6. That would be 30. That would be a 3 by arithmetic in the central box. And both that being a 6 and that being a 3 would make this a 7. Now, 7 is quite difficult here because it makes all of these add up to 42. It's doable. Those could be, well, that could be 98765 is 35, and those only have to add up to 7. No, they have to add up to 14, sorry, 49 for the total. That's still not hard to do. So, God, it's amazing how quick you get plunged into a world of complexity. 10 minutes. Don't know really when I came out of this thought about these things. Now, okay, say that was a 4. These would add up to 12 to make the 16 total. 12, 24. These ones would have to add up to 21. That's doable. Oh, but this is doing something as it goes around here. Yes, if that's a 3, these two add up to 6. Well, they can't be a 1-5 pair because that can't be a 1 or a 5. If that's a 3, this is a 4-2 pair. What does that imply? Feels like it does imply something. If that's a 3, that's a 4-2 pair. And that's a 5 in this circumstance. don't know. If that's a 3, that's a 5, that's a 6, that's a 4. Now, if this is a 4, these add up to 12. They're never huge, are they? Oh, I was speculating that if that was a 4, these added up to 12. And these would have to add up to 21. Well, I don't think that works in any way, because if that was a 3, you couldn't do it. If it was a 4, that would be an 8-9 pair, but either of 3 or 4 here would be impossible. 4 would take both the 8 and the 9, 3 would take one of them. That's not going to work. So that would have to be a 7. These would have to add up to 14. The 4 possibility wouldn't work. They can't add up to exactly 14 because 5 and 6 are gone. That's not a 4. Wow, that's 5 or 6. And it takes in either all of those cells leaving a 3 there by maths, or just those cells which add up to 20. With these adding up to 12, that's 32. These two would add up to 13. Well, they couldn't be 3, 10 or 7, 6 because we've already had a 6. They would have to be 4, 9. So if that's a 5, that's a 4. Now, what does that do? That makes these add up to 12. That's a 9. Oh, the 9. Right. The 9 there is in the sum from here. It can't be in the 3 sum. That would be a 4. So where did this chain of inference start? If that was a 5, yes, that was it. These were a 4, 9 pair then. And that would have to be a 4 to accommodate that 9. And you'd have to have 2 there and 1 there. If that's a 5, you end up with a 9 here and a 1 here. By maths, what did we say? This is, we said what it was if this was a 6. It has to be a 3. If that's a 5, you've got your 9, 4 here. That's a 4. So if that's a 6, that's a 3. If it's a 5, it's a 4. It's never a 7. Okay, well, at least that ruled that out. Now, this is 3 or 4 here. Now, if that's a 3, this is 5. And that's 4. That's 6. I'm interested in that being a 5, because it would... Yeah, this wouldn't work. No, it wouldn't work with a 3 here. So if that was a 3, 5 there would prevent a 5-1 pair there, so that couldn't be a 3 with a 5-1 pair. It also couldn't be a 3 with a 4-2 pair, because this would have turned out to be 4. So 3 there prevents that being 3. That's interesting. 3 here. Well, no, let's carry on. Maybe 3 here fails even with a 4 there. That would be the interesting step now. Ah. No, let's just think about a 6 here. That forces things that may be incompatible now. 6 here forces that to be a 4 on its line of 10 connecting them, and that to be a 5 by Sudoku. That 5 is what forces this to be 4 and that to be 9. So in that case, we've got 4s in both of those positions. Clearly a 3 here. Let me just try and show you that. What I'm seeing, I mean, it'll look like a bifurcation, but I'm seeing it in my head. If that's a 6, this has to be a 4, because otherwise this cell doesn't get into any line. So that has to be a 5 by Sudoku, so that's just counting those ones. That 4 means this is a 3 and that's a 5 to make that 9 work. That makes that 6. Now, to make the 5 work and how these add up, that leaves these two adding to 13, so they become 4 and 9. And that 3 is broken. That doesn't work at all. So 6 there does not work. That is a very hard conclusion to reach. If that is meant to be how you get into this puzzle, my goodness, I'm not sure it's a wonderful day for pi. It's a wonderful day for deep thinking. Anyway, that is a 7. Now, we need to draw these lines. Or no, I tell you, yeah, okay, I'm going to draw lines with the pen tool. So, let's draw an orange line up here that is 7 long. Those 1, 2, 3, 4, 5. Those 7 cells add up to 49. These 7 also add up to 49. Now these two have to add to at least 14 because the maximum for those is 35. 7, 9, 8, 6, 5. So those two add up to at least 14. Oh, 7 in the central box is in one of those two. That's getting interesting, slightly. 7 was our second digit here. We didn't even do the 3 and 4 from the pi. Now, if this is a 4, the 7's in the 16 sum with a pair that adds to 5, well, that can't be 4, oh, it could be 4, 1. You can have repeat numbers, yeah. This is now freed up to only be a 3, as is that, based on the length of the lines. So we are not done here by any stretch of the fevered imagination. Okay, let's imagine this is a 3. That has to be a 1-5 pair, which it can't be, or a 2-4 pair, which it could be. If that's a 3, that's a 2-4 pair. And this would have to be, no, it wouldn't have to be a 6. No, it wouldn't. It could be a 5. Okay, that didn't really get me anywhere. This is counting 3 or 4. If it's... Now, what did I work out here? I did do something before. If that was a 3, that would be a 5. I think this couldn't be a 3 anymore. This had to be a 4 then. Because that 5 prevented 5, 1. And the 3 being there made that a 4, and that prevents 4, 2. So that 3 would lead to that being a 4. Goodness, I don't know. One of these combos is impossible. Right, hang on. If that's a 5, we worked out that those adding up to 20 makes this a 4-9 pair. So the 7 would be there. So we would then have 7 here and 9 here. And that would break both the 3 and the 4 possibilities. So that is not 5. That's a 6. I'm looking at the 3 and 4 counting round the corner. Right, that's a 6. Let's do some more of our lines. Well, what does a blue line look like on top of blue? Let's try it out. Pointless. Absolutely rubbish. Right, it doesn't actually matter because I've just remembered that these now add up to 30 to make that 6 line work this way. Plus those makes that a 3. And that is now a definite 3. These two, I think that stops this being a 3. That's what I keep on working out again and again. Because if that was a 3, that's a 5, and this couldn't be 5, 1 or 4, 2. So that's a 4, that's a 3, that's the pi numbers done. That's a 5 and that's a 6. Here we go now. So that 6 must be fulfilled when we fill in 2, 4, 7, 8, 9 here. That will be the right sum. I'm just doing it in my head. It is 36. This 6 goes the other way as well though. So let's do a line here that is 6 long. There we go. And they will add up to 36. I don't know what this is. These are from 2, 4, 8, 9. That 3 needs to be fulfilled with either a 2, 4 or a 1, 5 pair running down here. That's not a lot of use, it feels like. So I'm going to have to think about this 7 line, which has got to have some big digits on. Especially if those were 9865, this would be a maximum of 4. So maxima along here are 987 in box 2, 98 in box 1. They add up to... Sorry, I'm thinking of other things. 24 and 17 is 41. Oh no, plus the 7 is 48. We only need a 1 there. That didn't even limit that cell. That's astonishing. Right, not to worry. Haven't thought about this line at all. What's it doing? Can't have a 7 there or there. Oh, that can't be a 6 or a 7. 8 and 9 are surely too big. Let's just check with 8. 987, 987. You're averaging 8 at that point. I suppose that could be a 987 pair. A 9-7 pair, I mean. Okay, I can't quite rule out 8. But otherwise, it's 5 or 3. Or can it be 1? No, because that would need this to be 9. These two have to add up to at least 10 between them. That's what we keep finding. Oh, this 4 I have not marked in the line. That is going to take... Oops, it's not like that. It's going to take row 2, column 2 as well. That's an overlap cell. And these add up to 16. Okay, I don't think that really helps. But let's think about this. If that was a 3... this would have to be an 8 or a 9 to get the whole line to add up to 11. Now, if it can't be a 9, 9s are ridiculous. If that was an 8, oh, these would only be 9, 7, 6, 22. You allow 9, 8, 7 there, you're up to 46. To get to 64, those would have to be 18. That is not a 9 or an 8. This is less. I'm going to put 6, 5, 4, 3, 1. None of these can be 2s, because they would need a 2 next to them. 1 is impossible, because that can't be the 9. Right. We need these 2 diamonds to add up to at least 10, remember. Now, I think 3 can be ruled out of here because of that very rule that I just said. So that is 5 or 8. 8 is very difficult, though. So let's just think about that again. 897, 987 or 986 there, and 97 or 98 there. Now, does that explode for some reason? It must do somehow. No, it doesn't obviously to me. I think it's incredibly unlikely, but that doesn't stop it being potentially possible. Whereas 5 just needs those to add to 25. However, 5 does require this to be a 5 or a 6. In fact, this is now 3, 4, 5 or 6. This one can't be 1 as a result of this line being 10 long as well. 2 for the same reason, but also because you can never really get a 2. So that is going to be 1, 3, not 1, 3, 4, 5, 6, or maybe 7. I think I can rule out 8 here, surely. 24, 54, 63 is the maximum. I can rule out 8 there. Sorry, I'm finding this very difficult. Let's hope for some Sudoku to come to the rescue. There's a 6 there. And a 3 somewhere there. That did nothing, did it? All of these cells are on lines. Is that and everything in box 5? Maybe there's a holistic add up. Oh, this pair. This pair is not. This is. I did not colour this line. That's a 9. A 3 average. That can't be 1, 5. Those are a 2, 4 pair. That is not a 7. Here we go, Sudoku now. That's a 7. 8 and 9 are definitely in these 2 cells, and now that has to be a 5 in the diamond by Sudoku. Everything else in the row is low, 1, 2, 3 or 4. That might militate against that being a 7, but we're not there yet. That can't be a 4 by Sudoku. Now these have to add up to 16. Those two are at least adding up to 9. This can't be a 2-4 pair because it would break that cell, so that's a 1-5 pair. Now look, 1, 5 and 3 are a double X-wing. Where do 1, 5 and 3 go in column 6 in those cells? This one could be a 1, which would be irritating. Actually, if it's a 3, neither of these cells can be 1 or 5. They would have to be a 2-4 pair. And if it's a 5, these would add to 20. And that wouldn't work because they're in the 6th sum of 36. 20 there plus a 6 there would leave 10 in this cell. So that's not a 5. And if it's a 3, that's a 2-4 pair. They add to 6. That's a 6. That's 12. These would have to add to 24. They would be 9, 8, 7. I bet that is what happens. 3 there, 2, 4 there. Oh no, no, because this 7's getting destroyed. If that's 9, 8, 7, the biggest these two can be is 6, 5. And this can't be 9, 8 or 7 anymore at all anyway. So you could have 6, 5, 9, 8. That's 28. Plus a 5 there is 33. Plus that 7 is 40. Plus a 9. So 7, 9, 5, 9, 8, 5, 6 just works if that's a 3. That all comes to pass. Oh, there's a 2-4 pair looking at that cell. So these are from 6, 8, 9 in the column. Yeah, let's do some Sudoku. 6, 8, 9, 1, 5. One of them's a 6. Goodness me. Oh, if that was a 9, which was what I needed for that to be a 3, that has an impact on this line. The maximum those could be is 7, 8, 6, 5, 4, which is 30. These two would have to add to 19. That's not going to happen. So that is a 1. What a paltry number to get into a diamond. It fulfills itself instantly, but that's disappointing actually. Now, no, it's no longer true. That was all about that being a 2-4 pair, and that's gone now. That doesn't happen. So these don't have to be 9, 8, 7 and put pressure on these. Oh, goodness. I mean, it was getting interesting. Right, I've got another 5 that I haven't marked there. Those 5 add up to 25. This can't be 3 or 4 because we wouldn't count that cell then. So this is 5 or 6. I suppose all of these digits could be 5s in the real solution. Now that's 5 or 6. 3 is gone from here because, where is it? That digit wouldn't get counted. Oh, now it's 5 or 6. These can't quite be 9, 8, 7, 6, 5 anymore. They can now be 9, 8, 7, 6, 4. That's 34. And these would add to 15. That's the new minimum for these two. 15 is the minimum there. So one of 2 or 4 is in these cells. 15 is the minimum. So 34 the maximum is what I'm saying here. Now, if this was 7, 9, 8, 6, 4 with a 5 there, that would max out at 3, which would also put a 3 there. You'd have 7, 10, 13. A pair of 9 8s would only get you to 47. That cannot be a 3. Okay, let's assume 9, 8, 9, 8 there is 34, plus the 7 is 41. These two have to add, this is an absolute minimum, to 8. The digit in this cell, absolute minimum, is 3. Now that's quite interesting, because can 1 be on this line? If it was 9, 8, 7, 6, 1, That would add up to 31. Those two would have to add up to 18. No, 1 is placed in this column there. That's weird. Now, 1's going to be on one of these. And if it was on the 6 line, that's coming under pressure. Let's imagine 9, 8, 1 there. That's 18. Plus the 6 is 24. Those would have to be at least 12. Okay, not too much pressure. Although, maybe I should be adding all of these cells, which are on the 6 and the 7 lines in their boxes. So the 6 and the 7 lines between them add up to 49 and 30. Why did I choose yellow when we had the gold cells originally? The blue cells add up to 49 for that line and 36 for that one, is 85. That's a maximum of 35 in that box, 35 in that box, 98765, that's 70, plus 6 and 7 is 83. Oh, bother, that didn't affect my minimum here at all. Oh, I'm quite surprised. I'm very irritated. Oh, rats. Okay, I'm going to have to think of something else. There's a 5 in one of those cells. That's just nonsense Sudoku. 1, 3, 5. There's a 6 in one of those. And that's not a 6, therefore. This line, or this line, or this one. I don't know what to focus on at all. Oh, there's a 1 in one of those cells. Right, let's go back to this thought about, what was my total? 49 plus 36, 85. If there was a 1 in one of those two, we've got a maximum here of 31. Plus 35 here is 66, 72, 79. That would have to be at least a 6. No, that didn't do anything. Sorry. 7 and a 5 there is 12. Let's just think about these again. Because this is going to be very, yes. Maximum there is 17. Plus 7 is 24. Minimum for these ones is therefore 25 to get to our 49 total. 25 in 4 cells without a 7. That's got to include 9 and 8. 9 and 8 have to be in that group of cells. Therefore, that is not 9 or 8. And now these are under some pressure. Right. Let's think again about a 1 being in that cell. 31 plus 35 is 66, 72, 79. That would have to be a 6. Oh, that's really interesting. That wouldn't work. That wouldn't work for a beautiful, beautiful reason. If this was a 6, then these cells have a maximum of 18. These cells have to add up to 31. I thought it was more. Sorry. Okay, but we're on to something here. 9 and 8 have to be in this group of cells. So does either 6 or 5. What did I say they had? 17 there, 24. These are minimum of 25. 9 and 8, they have them. That's 17. They need another minimum of 8. That must involve either a 6 or a 5. And one of the 6 or 5 is in those cells and the other one is there, and that one can't be 6 or 5. Right, now we can say 1 is not in these cells for a, I think this is, there might be more I can say. Let's just max these out at 16. That requires these to add up to 33 minimum. That's a 9-8 and 9-7 at the minimum. And that's going to be an X-wing on 9s, putting the 9 in row 3 there. It doesn't... Yeah. Well, this is huge. If that was 9-8, 9-8, where would 9 and 8 go in row 3? They can't go anywhere. Well, they could go in that cell, but only one of them. So those do not add up to 34. They have a maximum of 33. Plus that 7 is 40. These are a 4 and 5. We've done that. Didn't even need to think about all the blue area together. That was a red herring. That's not a 4 now. And now these do add up to 9-8 and 9-7 to make this sum work. So there's definitely a 9 in each box. That's now not a 6. And the 9 in each box does form an X-wing, and we can place that 9 here in row 3. And that must be a 9-8 and a 9-7 so that this whole thing works. It's really pretty, that. Now, the 6 thing, this has got, let's just get rid of the blue cells on the 7 line. The 6 line, however, has to add up to 36, and it's got a bit limited now. The most those can be is 8 and 6, because 9 and 1 of 8 or 7 goes there, so maybe 14 there, plus 6 there is 20. These would have to add up to a minimum of 16, and they're not allowed a 9, and only 1 of 8 and 7. So 8, 6, 5, I suppose. They can't have a 1 anymore, surely. Surely they can't have a 1. If they had a 1, 1, 8, 6 there, 8, 6 there, you can only get to 35, just short. Excellent, that'll do. There's the 1 in box 1. It's on the 4 cell 16 line. So these two add up to 11, so I'm eliminating 7 from that one and 1 from that one. Is that all that gets me? That was good work. This is a really mathematical puzzle. I mean, very appropriate for Pi Day, but I had not expected it to be like this at all. Right, we've got to do something more now. I still don't like these lines with their possible 5s in the diamonds. They're the least helpful things around. Let's keep going with the 6 line. Let's think about something else to do with the 6 line. Right, we ruled 1 off it there. Can it have a 4 on it here? Otherwise I could place 4 there. If that was a 4, this could be an 8. That would be 12, 18. These would have to add up to 18. 8, 6, 8, 6, 5 is 19. Okay, there's a degree of freedom there. Yeah, I don't know. That's tricky. Oh, no, I thought I could place a 3 here. That's nonsense. That's phantom Sudoku that occurs when your brain's getting feverish and desperate. I think there's still a long way to go in this puzzle, honestly. Oh, goodness. Okay, come on, Mark. Think, think, think. I love these 9s things. And one of them's an 8 and one of them's a 7. Now, come on, this line, surely it's got to have lots of high digits on. It doesn't have a 4 on it in any of the... It doesn't have a 4 on it in this box. Ah, is there a chance that means this box has to have a 6? Because I could place that if there was. I could place 6 there then. Right, if this didn't have a 6, yeah, that's good. The maximum this could be, if there wasn't a 6 here, is 8, the remaining digit from those, 5, and 3. They only add up to 16, plus the 6 there is 22. These two would be 8 and 6. And that is, no, that is not possible, because we'd have used 8 twice on the blue line, and therefore this line would be using 7 twice, and that doesn't get the total right. We can't use 8 twice in blue. That's really interesting. I'd forgotten that. Right. What I've proved is there is a 6 on this bit of the line, and it's there. That gives us a 6 here. Now, in these remaining 3 cells, we can use, well, what have we got so far on this line? We've got 19. These add up to 17. No, I shouldn't be counting the 1. I haven't been counting the 1. I haven't been counting the 1 before. We've got those, 18. These add up to 18. We're allowed 1 8 and 1 7 because the others are going to get used up here. 1 8 or 1 7. We're not allowed a 4. We've got to get to 18 in 3 digits. We could have a repeat in those 2 cells, but only if it was a 2, and it's not, because that wouldn't get us to 18. 2 and 2 and 14. So that's really interesting. These are 3 different digits now, because 8 and 7 are not allowed as repeats. There are 3 different digits that add up to 18. They're not 8, 7, 1, because we can't get a 1 in. They don't have a 6. I'm beginning to feel it's impossible. Oh, bother. Now, what I never ruled out before, I think, was 9, 7 in both places with a 7 there. And then I've made this total wrong. Oh, bother. I thought we couldn't repeat the number. This was here. Then I did the 9 there. That was fine, because that was X-winged. But then, look. Oh, bother. No, it wasn't fine, because I said these had to add up to exactly 33. But they could add up to 32. No, it was max. 5 and 4, it was max. It was all right. That was all right. But I don't understand how I'm going to get this 36 line right now. 18, and these have to add up to 18. I'm pretty sure they can't be a repeat digit. And we can't use 6 or 1 or 4 or 9. Got 8, 7, 5, 3, 2. We have to use 3 different digits to make 18. There's no way. What have I done wrong this? I don't understand. It was all working. It was happening perfectly. No repeat digits, because one of these pairs has an 8 and one of them has a 7. That's right. Putting the 6 there was mandatory. Okay, maybe I was wrong to calculate that 6 had to be on the line somehow. But you can't put 8 and 7 here. One of these is a 6 by Sudoku. So if that's a 6, that is definitely a 6. And these have to add up to 18. I think I've worked out several times that cannot occur. 87532 are the available digits. I still think I'm sort of on the right track, but I cannot get this. Sorry. There must be a possibility that I cannot think of at the moment. If that's a 6, that is a 6 by Sudoku. Well, hang on, why? Oh, I had a 153 triple. Yeah, that was maxed. That was max at 4 because of this column. Now, if I missed something in this column, could that be a 5? That would be a 6. You'd have 9832 here, plus the 7 is 29. Those would have to add to 20. I haven't missed anything there. Did I add this line wrong? 16 plus 33. No, that's 49. That's all right. I cannot see what I've done wrong. I feel so close on this somehow. 149, 8 and a 7. 6 and 6 is what leaves that to be 18. So if that wasn't a 6, these could be 8, 5, 3 in some order, I think. But then these were 7, 6 at the most. 8, 5, 3 is 16, 22. Yeah, 7, 6 just misses it. Okay, let's just go. Shall I go back a bit? Let's go back a bit to where I put the 5 and the 4 in on the 7 line. Let's leave it there. That was 4 or 3. Now, these are absolute minimum. 9864 now. That's the 34, which leaves 15 there. If they were 9864, that would be a 5 and that would be a 3. But this line just couldn't work. I can't ignore that. This can never be an 8. I worked that out very carefully. So let's say 9863 is the maximum here. $26. These then have to add up to 16. There's 1 degree of freedom. So 986. Oh yeah, 98. I was going to say 9 and 8 are unarguable. Ah, so annoying. Why can't I work this out? Nine, 8, and 9, 7 there. 33, 40, 4 and 5. Okay, I think that's right. I'm just not arguing with myself about that anymore. Okay, so that part is correct. Now, it's this line again. Oh no, the 1. Was that, is there any, maybe I was adding that 1 in somehow when I got this wrong. Is there a chance of that? If there was a 1 here. Trouble is you can only have 1, 8 and 1, 7 in these cells. Yeah, which is only going to get you 2 digits above above the average. Well, 8 and a 7 gets you 3 points above the average. 1 would take you far too low. So let's say there is an 8, 7 here to get you above the average. Then you could have 6s and a 3. Oh. The 2 6s, 3 and 8, 7. For some reason I thought you couldn't have 8 and 7 on this line. Do you know why? Because of just awful arithmetic in my head. Somehow I thought 8, 7, 1 equals 16, which it does, but I thought that mattered. But I'm actually looking for an 18 total. It's okay. It's okay. We can put that 1 in. It can't be on that line. Here we are. Now, the 6 is necessary there. It's 8, 7, 3 are the other digits that don't include a repeat. All my thinking was right. It was just my little bit of arithmetic that was rubbish. So this group of cells is 8, 7, 3. That's how it works. The 3 goes there. This is a 7, 8 pair. Now we've got 7, 8, 9 triple. We can fill in. I think Sudoku could do an awful lot of this puzzle for us now. That's a 5. Now, to make sure, 1, 2, 3, 4, 5, that that cell is included. Oh no, that doesn't stop this being a, never mind. Let's do as much Sudoku as I can. We've got a 4 in box 1 and 2 and 5. Oh, just breathing a little easier now. 4, 3, 6, 5, 1 and 9. These are from 2, 7 and 8. Now this 5, this line is worth thinking about. Oh no, this line is worth thinking about. Of course, we've lost the 4. Yes. 9, 8, 6, 3, because that has to be 6 or 5. 9, 8, 6, 3 is the maximum here. Taking us to 33, this is now minimum 16. That was right. So one of those is a 9. That's not a 9 now. We've got an 8, 9 pair in the column. That is in fact a 6, which puts a 5 on the diamond. All these diamonds were 5s. How painfully predictable. Right, now these are 9, 8, 6, 3 definitely, or 9, 8, 6, 2? Don't know. Oh yes we do, because that one can't be a 2. So that's a 3. This is 9, 8, 6, 2 down here. Some of those digits will be impossible. 6 there, 9 there are impossible. Right. 9, 8, 6, 2 add up to 25, plus the 7 is 32. These two are now adding up to 17 to make the 49. So that is a 9, 8 pair. In this box, these are from 2, 4 and 7. And this 5 total has a 7 there. So we've got 7, 6 and 5, that's 18. Plus either a 4 and a 3, which is impossible, or a 2 and a 5, which is not only possible, but necessary. So there we go. That one adds up to 25. The 5 there gives us Sudoku to do. That has become a 4, that's a 2, that's not a 2. One of these two is a 2. That's not been a 5 for a while. 4, 6, 5, 2 is in one of those two cells. 2 in column 3 is definitely here. 3, 6, 4, 2, 5. That is 1, 8, or 9. Oh, there should be more Sudoku available as a reward. Right, let's have a look at this line, because if that wasn't 2, if that was 7 or 8, I don't know, these would just have to be low. Oh, 5's got placed here. I hadn't seen that. Is that all the 5s in the grid now? That was the last one. Okay, so let's draw the lines. We've got one that goes to there, and the other one from this end goes to there. I don't know, is there some holistic maths on that? I don't. These add up to 20. These add up to 25. That's one set of 45 for the 2 columns. I don't know. I don't see what else I can do on the rest. No, don't make me do that maths. Oh, 2 there has taken 2 out of those cells. This is a 4, 8, 9 triple. Those don't have a 4 in there, and they do have a 1 in. And there's a 1 in one of those cells. That's not a 2. Oh, I thought we'd found 2 on this line. That's not an 8 in this row. Now, if that was a 1, it would balance off the 9 on the 5 line. That would be interesting. Three, 5, 2. We need a 4 in one of those cells on the line. Interesting. That's just Sudoku. Oh, 4 is placed in box 5. I hadn't seen that. Could maybe colour these 8s and 9s, but I don't know quite, or 7s, 8s and 9s. I don't know quite what it would do. That's a 7, 8 pair. Yeah, I mean, those lines are effectively finished. Right. If that was low, what with that being so low, this would be quite high. Oh, I don't know. Okay, still need work to do here, or still need to do some work. 8, 9, oh goodness, 5, 6, 4, 3 and 2 are confined here. Okay, 4's on this line. That's so uninteresting. 3, 1, 4, 5, no. So whatever this is, no, I was going to look for it in the box below. It doesn't really do anything. Oh, I don't know. There's a 2 in one of those cells. Now we know these 2 add up to 11 on the red line. Five is such a annoying averagey number for these mean diamond rule sets. It just doesn't do a lot. That can't be a 9 because those would both have to be 1s to balance out the averages. If that was an 8, this is a 1 and that's a 2. However, if this is low, that's pretty high. Hang on, maybe this line is better than I realized. These 3 remaining digits have to add to 11. That's all they can do. If that's an 8, we need a 1 in the other 2. And that would be here. If that's a 2, that would have to be 8 and 1. If that's a 3, that would be 7 and 1. This is always a 1. That is peculiar. Now these 2 digits add up to 10 in their column. And that's not a 1. Now, what does that mean? These 2 add up to 10. Oh, I'll tell you what it means. This is lovely. If this was a 4-6 pair here, which is very possible because 6 is in one of those cells and 4 is in one of those. If this was a 4-6 pair, you've got 10 and a 5. Those would add up to 10. But they couldn't be a 4-6 pair because of those. They couldn't be a 1-9 pair because of that cell seeing 1 and 9. They couldn't be from the orange pair. And this cell, violet, would be from the other pair. So if that was 2 or 8, that would be 3 from 3, 7. If that was 3 and 7, that would be 2 from 2, 8. And this would have no identity if that was a 4-6 pair. And we know there's a 4 there, so 6 we now know isn't there. That is incredible, by the way. That is an incredible thing to happen at this stage of this Sudoku. Absolutely extraordinary. I mean, if you have to do that, wow. Now, I wonder if it's the same thing. Can I always avoid putting 6 on this line? Because I'd be left with another pair. No, I don't think so, because that pair could involve... It wouldn't even have to be in this column. No, it's not. It only worked for that pair. Now, what have we got left in this row? 3, 4, 6, 7. 7, 1, 5. One of these is 4. We know that. We know these two add up to 10. Why isn't it telling me anything else? That 1 we got rather excitingly latterly. So one of these two is a 1. And if it was on the line with a 1 and a 4, the other two digits on the line would have to add up to 15. Okay, there are ways that can happen with a 6 or a 7 here. So that's not that exciting. Goodness me, it's amazing what can stun you in a puzzle still. I mean, that pair thing, that was weird and exciting. That digit's in one of those and somewhere down here. Oh, goodness. I feel like I'm nowhere near the solution now. Should I mean, I can uncolour these blues. That really did its job hard at one point, didn't it? Now that must be one of the orange digits for what it's worth in this row, because it's the other one of 2, 3. I don't think that's going to be worth an awful lot, but it is true. Come on, let's find something else. Please help me. These are from 6, 7, 8. Now, if that was 7 or 8, then in this column we would have a 2, 3, 7, 8 quad. These would be from 1, 4, 6, 9 on this line. And they would, all the digits on the line would have to be from 1, 4, 6, 9 then, because they add up to the number. And that would have to be a 4, because it sees 1, 9 and 6. So it would definitely then go 4, 9, 1, 6. And that would be another 4. And that's if this is 7 or 8. If it is just 6, well, 6 is now in one of those two cells in the column. If it was 6, I don't know. I don't know if that does anything at all. It was a lovely complicated thought while it lasted, and then it died. But I still think it's very interesting whether this black line has pairs that add up to 10. This one did, had a pair there and a pair there. This one didn't, interestingly. It had another 5, so it didn't have pairs that added up to 10. I mean, I don't think they're mutually exclusive groups. But you do have to think about everything. Right, there's a 4 in one of those positions. Come on, what does that mean? Two in the final column is there. Look at that. How is that so obvious now? The 2 there and the 2 there rule 2 out of those cells. Now, this is not 2. This is high, and this one is low. And that's a 2, 3 pair now. These are from 4, 8, 9. 8 or 9 is quite a high digit. He said, fatuously. No, that is not fatuous. Because there must now be a low digit here to match off. 8 or 9 cannot, they're 3 or 4 over par. They cannot be matched off by a 4, which is just 1 under. So we need another digit, which is at least 3 under par in these two cells, and we can't use 2 or 3. If we used 4, that doesn't go enough under par, so we've got to use the 1 now on this line. I mean, that's weird. What is this under par, over par nonsense I hear you say? It's just how I'm thinking about this. Now, that is very heavily under par, and the 4 is a bit under par. They are 5 under par. The 5 over par are achieved by a 9 and a 6, or an 8 and a 7. So this is quite a high digit, 6 or 7. That's a 6, 7, 8 triple. This isn't 8, and this is 4 or 9 in the column. Now, in this final column, that is not a 9.
2915. This is 6, 7 or 8. This is 3, 4 or 8. This can't be 8. Has anything happened in this box? No. 3's in one of those cells. There might be some weird impossibility here. So, if that's a 6, then that's a 9 and that's a 4. But if that's a 7, then we need the 4 and an 8, do we? Yes. If that's a 7 and that's an 8, it's okay. This works. Bother! These are from 6, 7, 8, 9 by Sudoku now. That is over par then. Oh, and this digit is over par. It sees 1, 2, 3, 4, 5, 6. So these are both over par. And they're both at least 2 over par. So these have to provide at least 4 under par between them. And this can't be high anymore. It can't be 6 or 7 because that would take us 5 over par and make this a 0. So that's low. This one, what can it be? By Sudoku, 3, 8 or 9. No, if this was 8 or 9, we'd be way over par. That's the 3. Oh my goodness, this is just doable. 2, 3, 8 for that line there. This becomes a 2. Let's get rid of the colours. They're done. This is 8 or 9 in its row. Those aren't 8. That's a 6, 7 pair. Let's take 7 out of those cells. Now, that's the 8, 9 pair. This is the 7, 9 pair. So we can fill them in. And these cells are done. 7 and 8. That does these. 9, 8. Oh, Sudoku, come to Mark's rescue now, please. Don't stop just when I say that. That would be mean. That's not an 8, and that's not 7 or 8. 3, 5, 2, 6. Right. This line, 2 under par there. It's going to go at least 4 over there. So those are both 7s, and that's a 3. The line goes 5, 3, 7, 7, 3. That's all it can do. 6 there. That gives me 7 here. Now I can add up this other line, or I can just do it by Sudoku. Let's hope that that is the right sum. It is, 25. What a relief. 3 in the corner. That's 3 in the spotlight. Proving its position. Trying to keep up with you. That's an 8. That's a 1. That's a 9. This is 1, 4, 8. I mean, if I get the tick here, it's so well earned. Oh my goodness. I'm very pleased to get through that. It is a wonderful day. 70 minutes to the second. But my goodness, that was tough sledding. Okay, it wasn't helped in the middle by my inability to realize I was adding to 18 or then to add to 18, whichever it was. It took me a long time to get through that hurdle, but that was probably only 5 minutes of the 70. That was a hard puzzle. What an intriguing idea. Well, didn't do it on International Pi Day, but we did do it eventually, and I'm very pleased with the solution there. Thank you for watching. Hope to see you again soon on the channel. Bye for now.